Okay, let's dive right into the psychology and engineering behind the digital interfaces we literally touch every single day.
Chapter 1. Introduction to Advanced User Interfaces. Chapter 2. User Interaction. Chapter 3. UI Toolkit. Chapter 4. Interaction Techniques. Chapter 5. GUI, VUI, and Gestures. Chapter 6. Crafting Advanced UI. Chapter 7. Planning UX. Chapter 8. Multimedia UI. Chapter 9. Design Challenges. Chapter 10. Testing and Personalization. Chapter 11. UI Development. Chapter 12. Continuous Improvement. Chapter 13. Adaptive Interfaces. Chapter 14. Good UI. Chapter 15. Evolving Interfaces. Chapter 16. Mobile and Multimedia. Chapter 17. Emerging Technology. Chapter 18. Advanced UI Concepts. Chapter 19. Interface Components. Chapter 20. Responsive Design.
Today, we're unpacking the ICT PRG 535 Learner Guide on building advanced user interfaces, and we're going to explore exactly what it takes to create an experience that feels completely seamless.
Because let's be honest, when the human-screen relationship goes wrong, things can get pretty intense. The source material actually points out a case where a user dropped his PC from an upper floor window in pure exasperation, or another who literally relieved his annoyance by shooting his computer with a gun. No joke. When interfaces are complicated or unreliable, they don't just slow us down, right? They generate real, visceral anger. And the stakes for getting this right are absolutely massive. Bad design doesn't just cause a spike in blood pressure, it costs astronomical amounts of time and money. Think about a system processing 4.8 million screens a year. If a poorly designed layout costs a user just 20 extra seconds per screen, that instantly adds up to 14 lost person-years of productivity. And it gets worse. In critical fields like air traffic control or nuclear power plants, a bad UI doesn't just waste time, it literally risks public safety. So, digital nightmares, we're going to follow the journey of a screen through 5 critical UI development phases. 1. Planning the user experience. 2. Designing seamless interactions. 3. Personalization and customization. 4. Graphics and multimedia. And 5. The never-ending process.
Chapter 1. Planning the user experience.
The stark contrast between getting it right and getting it wrong here is really foundational. The ultimate goal of a good UI is to actually be invisible, It just gets out of your way. When researchers reformatted screens to follow good design principles, they found users performed transactions up to 25% faster than with the original layouts. Good UI means faster completion, lower errors, and happier users. Poor UI, on the flip side, permanently scares people away and absolutely destroys customer confidence. Now, to achieve that kind of invisibility, you need the right tools. Industry standards like Figma, Sketch, Adobe XD, and InVision form the absolute backbone of modern UI design. Deciding which one you use really depends on your specific platform, whether you need heavy wireframing, and how your team collaborates. Figma, for example, being entirely browser-based, makes real-time collaboration just incredibly smooth. But hold on, before you ever even touch those tools, you've got to build a conceptual model. You need to understand the user's goals first. You have to ask the critical questions. What does the user actually want to achieve? What tasks are they performing? What exact information do they need to see? If your conceptual model doesn't match the user's actual day-to-day tasks, they're going to be instantly confused no matter how pretty your color palette is.
Which brings us to Chapter 2, Designing Seamless Interactions. First, we have to understand what an interaction actually is. Essentially, this is the fusion of hardware and software that translates human intention into computer action. Whether you're using a traditional mouse on a GUI, your voice with a smart assistant, or using body gestures in 3D spaces, an interaction technique is just a way to execute a task in this ongoing back-and-forth dialogue between human and machine. And the core of this dialogue is the interaction loop. It's a constant 3-step cycle. First, you provide input through a device. Second, a piece of software interprets that input into computer commands. And third, the system fires back visual, auditory, or even tactile feedback. If any single part of this loop lags or fails, the whole illusion of a seamless experience just completely shatters. A perfect, everyday example of streamlining this loop is client-side validation. You know, when you type an email address into a form, accidentally miss the @ symbol, and instantly get a little red error message before you even hit submit? That is client-side validation in action. It instantly checks user data right there in the browser. It gives you significantly faster feedback, and as a massive bonus, it drastically reduces unnecessary requests and load on the backend server. But a quick, crucial warning on these interactions. While using familiar design patterns like breadcrumb navigation or progressive disclosure is highly encouraged to help users out, we must absolutely avoid dark patterns. These are unethical, deliberately confusing interface designs created specifically to manipulate users. Think of how incredibly difficult some sites make it to cancel a subscription, or how they trick you into opting into marketing emails. Good design builds trust. Dark patterns absolutely destroy it. Moving on to Chapter 3. Personalization and customization. So there's a really crucial distinction here that often gets mixed up: the difference between personalization and customization. Personalization happens automatically in the background. The system does the heavy lifting, analyzing your behavior to adopt the content, like Amazon recommending products or Netflix suggesting a movie. It reduces your effort. Customization, however, puts the control directly in your hands. It's when you actively choose to turn on dark mode, increase the font size, or shuffle the layout. Both are absolutely essential for truly advanced UI. Building these beautifully tailored experiences requires a massive development process, from requirement gathering to wireframing and prototyping, and it all culminates in collaborative usability testing. During this phase, designers frequently use something called the Think Aloud protocol. They literally sit real users in front of a prototype and ask them to speak their exact thoughts out loud as they navigate the screen. It is the most raw, honest way to find out if your design actually works in the real world. All right, Chapter 4, Graphics and Multimedia. This is where we implement images, audio, and video to create richer, more engaging interactions. But we have to be incredibly careful here. One major rule is to avoid excessive or constant movement that distracts the user from their core tasks. A UI shouldn't look like a chaotic video game unless it actually is one. Also, rather than reinventing the wheel, professional developers rely on existing graphic libraries. This saves massive amounts of development time, ensures consistency across the whole application, and drastically improves maintainability down the road. Finally, Chapter 5, the never-ending process. Because the truth is, a screen's journey is never truly finished. The moment a UI is deployed to the public, that's just the beginning of a whole new phase. We have to constantly collect user feedback, run analytics, and roll out updates. User needs change, technologies evolve, and we must ensure our design remains inclusive, highly accessible, and totally frustration-free. If a UI stays stagnant, it's eventually going to break the user's trust. So, I'll leave you with this final provocative thought to reflect on your own digital environment. Does the software you use every single day adapt to your needs, or does it force you to adapt to its flaws? Take a hard look at the apps on your phone and the screens you use at work today. I really hope this explainer has completely changed how you look at the digital world around you and given you a newfound appreciation for the incredible science of user interface design. You're trying to accomplish a simple task, but the screen is a mess of overlapping elements, dense text, and tiny targets. You end up hunting for what you need, fighting the interface just to click a button. That half second you spend searching feels like a minor everyday annoyance. But when you scale that hesitation across thousands of users, it becomes a massive, silent drain on an economy. Take a typical enterprise system processing 4.8 million screens a year. If a confusing layout forces users to pause for just 1 extra second per screen, that tiny delay aggregates into an entire person-year of lost labor. In high-stakes environments, that inefficiency is dangerous. If an air traffic controller squints to parse multiple crowded monitors, a 1-second delay jeopardizes public safety. Early software was built to mirror machine logic, exposing complex back-end processes directly to the human. The modern solution is to design around human cognitive limits, stripping away friction until the interface becomes completely invisible. This practice is known as human-computer interaction, or HCI. It is an engineering discipline dedicated to matching our digital tools to our physical constraints and mental capacity. A central biological reality guides this work. Humans do not read digital interfaces. We scan them, hunting for shapes and visual hierarchy to tell us where to go.
When researchers take a crowded display and pull merged objects onto separate lines, they give the brain room to process the information. Users working with this uncrowded layout immediately become 20% more active and efficient. Predictable visual patterns drastically reduce the mental processing time needed to navigate. Take a flat, ambiguous shape on a plain background. Add a simple drop shadow, and you create a visual affordance. Your brain instantly recognizes it as a clickable button, without conscious thought. By aligning the visual layout with how our brains naturally scan, designers erase cognitive friction. You stop thinking about the tool entirely and focus on your task. Our attention is also heavily influenced by motion. The human brain is biologically wired to lock on to sudden movement in our peripheral vision. This is an ancient survival instinct. Millennia ago, noticing a rustling bush out of the corner of your eye meant spotting a saber-toothed tiger before it could strike. Today, our screens frequently trigger that exact same biological reflex. Like autoplaying videos and flashing banners, hijack our attention constantly. When an interface bombards you with unnecessary multimedia, it exhausts this reflex. It scatters your focus and makes interpreting the actual information you came for incredibly difficult. Because we are evolutionarily wired to detect these visual threats, effective UI limits motion. It reserves animations strictly for critical updates, protecting the user's attention instead of demanding it. We also have unique workflows. Forcing every single user into a rigid, one-size-fits-all digital experience is like a restaurant forcing every customer to eat onions, completely ignoring their individual needs. Personalization solves this by allowing the system to actively adapt to a user's profile, like a travel site automatically highlighting discounts for destinations you recently searched. Customization puts the user in control, allowing them to manually adapt the system. You might rearrange your dashboard or select specific global cities to monitor on a weather app. By anticipating what you need, these methods bypass complex task flows entirely. You can authorize a purchase with a single seamless gesture. Both personalization and customization drastically reduce friction because they shift the heavy lifting. Instead of relying on human memory to navigate menus, the underlying software does the work. When developers let go of their assumptions and build systems using these friction-reducing principles, the results are highly measurable. By reformatting screens with human-centric layouts, workers are able to perform standard transactions in 25% less time. More importantly, they execute those tasks with 25% fewer user errors. These principles are now expanding far beyond the flat screen. Voice-controlled interfaces strip away visual layouts, forcing designers to build clear interactions entirely through spoken commands. And as we move into spatial computing and virtual reality, our digital environments become completely immersive. In these 3D spaces, minimizing cognitive load and visual noise is critical to prevent overwhelming the user. Whether you are tapping a screen, speaking to a smart speaker, or navigating a virtual room, the goal is exactly the same. The interface should simply get out of the way, freeing you to work faster and more safely.
We are going on a step-by-step journey into how advanced user interfaces are planned, prototyped, and brought to life. We're going to demystify that kind of magical process of taking a completely blank screen and turning it into an intuitive, powerful bridge between humans and machines. We aren't just looking at drawing pretty pictures today either. We're diving deep into setting up the development environments, the software, and the servers that actually make these designs work in the real world. So whether you're a budding designer, a curious developer, or just someone who uses software and wonders how it all comes together, you are definitely in the right place. Okay, let's take a quick look at our roadmap for today. We're covering 1. The power of good UI. 2. Interface types and hardware. 3. Your UI prototyping toolkit. 4. Implementing user interactions. 5. Customization and personalization. And finally, 6. Integrating graphics and multimedia.
So, let's jump right into section 1, the power of good UI. Have you ever wondered why, honestly, despite all our incredibly advanced technology, massive budgets, and super powerful computers, we still run into completely unusable screens? We've all been there, right? Clicking endlessly, unable to find a simple button, getting totally lost in an app, or fighting that universal urge to just throw a frozen computer right out the nearest window. So, why does this still happen? Well, It's a super common myth that developers just don't care or that we somehow lack basic common sense. Look, if UI design was just common sense, every app would be perfectly intuitive right out of the gate. The real culprits usually come down to a severe lack of time and a genuine lack of understanding of what makes a design truly good. We often have to take our absolute best shot under immense pressure to ship a product, and unfortunately, sometimes the outcome falls drastically short of what users actually need.
Moving right along to Section 2, Interface Types and Hardware.
The core of human-computer interaction, or HCI, is fundamentally a high-wire balancing act. As designers and developers, we have to balance human skills, our physical constraints, and what people actually find fun, with the strict, cold limitations of computer hardware and software. It is entirely about translating human intent into machine action completely seamlessly. The crucial thing to remember is that interfaces aren't just flat screens anymore. They represent a continuous evolution of required hardware. We've gone from clicking in a standard graphical user interface, which needs physical hardware like optical sensors and a mouse or a trackpad, to speaking directly to voice-controlled interfaces like Siri or Alexa. Those require highly sensitive microphones and specialized audio processing chips. And now we're even moving our hands in 3D gesture-based spaces, which rely on spatial cameras and infrared sensors to track depth and movement. Each of these physical hardware devices requires a totally different approach to both design and prototyping.
That brings us to Section 3, your UI Prototyping Toolkit. Knowing your materials and the required tools, software, and licenses for UI implementation is absolutely vital. For visual design, tools like Figma are browser-based, which makes real-time team collaboration a breeze. Others, like Sketch, are super powerful for wireframing, but require a yearly Mac license renewal. And then there's Adobe XD, which is natively supported across multiple operating systems if you need to prototype voice interfaces alongside mobile apps. But here's the really critical part. UI isn't just drawing pictures, it's coding. Once that visual prototype is done, developers need a solution to actually apply the UI design. They use an integrated development environment, or IDE. Think of your prototyping tool as the architect's blueprint and the IDE as your fully equipped digital builder's workshop. Instead of writing code in a basic text notepad, developers use IDEs like Visual Studio Code or Eclipse. These robust environments provide real-time error checking, color-coded text, auto-completion. They're basically the power tools required to build the actual working software from those initial blueprints.
All right, Section 4, Implementing User Interactions.
It is highly vital you understand this concept right here. An interaction technique isn't just some lofty design idea. It's the literal, energetic fusion of input and output. It's the exact moment when your physical hardware, like clicking that optical mouse or swiping a glass screen, triggers the underlying code built in that IDE workshop, which then instantly updates the screen to give you visual feedback. Without that fusion between hardware action and software reaction, you literally just have a static picture on a screen, not a living interface.
Let's look at how systems actually validate the data you type in, which relies on a client system and a server system working together. Think of it like a restaurant. Client-side validation happens right in your local browser. It's like a waiter checking if you filled out the order card correctly before they even step away from your table. It's lightning fast, practically instantaneous. Server-side validation, however, happens on the back-end web server, like the kitchen checking the pantry to see if they actually have the ingredients for your order. It's way more secure, but it takes networking time. Now, to build and test all of this locally before going live to the public, developers use software stacks like WAMP server. In layperson's terms, WAMP server turns your normal everyday computer into a mock web server. It lets developers test exactly how the client browser and the backend server communicate safely, right there on their own desk, step by step, without even needing an actual internet connection.
Moving to Section 5, Customization and Personalization. You know, we often build for this mythical, ideal user, but the reality is everyone is completely different. If you run a digital restaurant, you don't force everyone to eat the exact same meal with the exact same ingredients, right? We have to give users the flexibility to shape their digital experience piece by piece. Providing that tailored environment is exactly what turns a frustrating tool into an indispensable one.
The big difference here really comes down to who is actually in control. You give the user absolute power with customization. They're the ones deciding to rearrange their dashboard or manually pick specific cities for their weather app. But with personalization, the system itself does the heavy lifting. In the background, the software classifies you based on your habits and serves up targeted content automatically. It's wild how fast this works. Algorithms on platforms like Amazon or Netflix can update your entire personalized profile based on just one or two seemingly random clicks, seamlessly altering what you see next to keep you engaged. Both of these strategies are incredibly powerful tools for making an interface feel like home.
And finally, Section 6, integrating graphics and multimedia. Constructing the final interface is a highly hands-on, deeply creative process where you're actively synthesizing text, sound, video, and complex animation. To pull this off, designers rely on dedicated multimedia tools. Think heavy-hitting software like Adobe After Effects for motion graphics, or specialized digital audio mixers for sound cues. In layperson's terms, these multimedia tools aren't just for making things look pretty. They generate the actual visual and auditory assets that we then plug directly into our coding IDEs, like Visual Studio Code or Eclipse. By pulling all these varied media components together, we effectively mask the incredibly complex code running in the background, giving the user something beautifully simple and intuitive to interact with.
By carefully integrating these multimedia elements, we drastically improve how everyday people perceive and understand complex computer-based applications. It elevates a simple utility tool into a rich experience of digital storytelling. But this firmly demands a careful design framework. Look, if you just dump 10 auto-playing videos and 5 flashing animations onto a single screen, you don't have a user interface. You just have digital chaos. Consistency and a rigid framework are absolutely key to ensuring these elements actually aid the user's workflow rather than totally overwhelming or distracting them.
I want to leave you with this final thought today. Unlike a printed book or a physical piece of machinery, digital screens are a totally malleable medium. We've gone on a massive journey today, right? From the initial visual design blueprints and tools like Figma, straight into the coding workshops of IDEs like Eclipse, and even testing our data on local WAMP servers to see exactly how clients and servers talk. It takes a brilliant symphony of software, hardware, and multimedia tools to truly bridge the gap between human and machine. So as you continue your own learning and building journey, ask yourself, how will you combine these incredible tools to bend this medium and create the ultimate user experience? Thanks for joining me on this explainer. Keep building, and we'll see you next time.